1, 2, 3, let's go!
Hey guys, it's me, Ashley, the math tutor. Welcome back to my YouTube channel. Alright, let's get started with today's video. So in this unit, we are going to be talking about trigonometric integrals using substitution, or basically trig integrals with higher powers. So basically in this unit, we're going to work on integrals that look like this, like these basically. So we're going to work on integrals that look like this: sine x to the n power times cosine x to the n power dx. We're also going to work on the integral of tan x to the n power times secant x to the n power dx. Also, we're going to work on integrals that look like sine x to the n power dx, cosine x to the n power dx, tan x to the n power dx, and secant x to the n power dx. Also, all of the exponents, like all the powers, m and n and m and n and all of these, all the powers, they're going to be greater than or equal to 1. Usually greater than 1, but it could be equal to 1, but all the powers are going to be greater than or equal to 1. That's why I said higher powers and stuff. So for topic 1 of this unit, I'm going to be doing 3 videos on integrals that look like this: the integral of sine x to the m power times cosine x to the n power dx. Topic 2, I'm going to be doing 3 videos on integrals that look like this: the integral of tan x to the n power times secant x to the n power dx. And for topic 3, I'm going to do 2 videos on integrals that look like this, which are basically, they're basically the individual trigonometric integrals. So the integral of sine x to the n power dx, the integral of cosine x to the n power dx, the integral of tan x to the n power dx, and the integral of secant x to the n power dx. Alright, so like I said in the previous clip, so now in this video we're going to be working on topic 2. Topic 2 in this unit, I guess, is scenarios that look like this: integrals of tan x to the n power times secant x to the n power dx. So we're going to be working on integrals that look like this. When it comes to integrals that look like this, there are 4 possible scenarios. Scenario 1 is where m, which is the exponent for the tan function, and n, which is the exponent for the secant function, are both odd. Scenario 2 is when m and n are both even. Scenario 3 is when m is odd but n is even, and scenario 4 is when m is even and n is odd. So that's what we're going to be working on in this video. Okay, so here are some really important things to remember for this topic. I'm going to be referring to certain things throughout the video as equation 5, equation 6, rule number 1, and rule number 2. So these are equations 5 and 6, and these are rule number 1 and rule number 2. So equation 5 and equation 6 are just trigonometric identities. Equation 5 is tan x squared is equal to secant x squared minus 1. Equation 6 is secant x squared is equal to 1 plus tan x squared. Rule number 1 and rule number 2 are just algebra and stuff, but it's important for this, topic, so just a reminder. So x to the power of a plus b is equal to x to the power of a times x to the power of b. And also, like in reverse, x to the power of a times x to the power of b is equal to x to the power of a plus b. So if a plus b were like numbers, right, and x was raised to the power of a plus b, this term can be broken down into x to the power of a times x to the power of b. And also, if it's x to the power of a times x to the power of b, to combine this, you can add the exponents, x to the power of a plus b. But if they're added, always remember that when you break it down, you multiply it. And if it's being multiplied and you're combining it, just remember that the exponents, you add them. So that's rule number 1. Rule number 2 basically is, this is rule number 2. It's also just another algebra thing. X to the power of a and all of this whole term to the power of b is equal to x to the power of a times b. And also in reverse, x to the power of a times b is equal to x to the power of a and this whole term raised to the power of b. So if it's a term raised to the power of something, and that whole term that's raised to the power of something, that whole term is raised to another power, to combine it, you can combine it such that it can be x raised to the power of a times b. They're times if it looks like this. If it's x to the power of a number and the whole term is to the power of another number, then to combine them, you can do x to the power of a times b. The exponents are times. And also to like break it apart and stuff like that, x to the power of a times b, if the exponents are times, you break it up like this, like x to the power of a and this whole term to the power of b. I'm going to do a little example of rule number 1 and rule number 2. I already did an example like this in the previous video, so I'm just going to insert the clip where I did an example of rule number 1 and rule number 2 now. Okay, so before we continue, I'm going to do a little example of rule number 1 and rule number 2. So first off, I'm going to start off with rule number 1. Rule number 1. So let's say we were to do x to the 4th power times x to the 7th power. As you can see, these are two terms that are like have the same base, and then they're being multiplied by an exponent. For that, if it's two terms being multiplied with the same base being multiplied by each other, you can add the exponents. And also you multiply the coefficients, but here the coefficients are just 1 times 1, so that's going to be 1, so it'll just be still 1x, which is just x. So x to the 4th times x to the 7th, that's going to be x to the 4 plus 7, which is going to be equal to x to the 11th. Conversely, x to the 11th is also equal to x to the 4 plus 7, because x, oops, my bad. Let me rewrite that 4. X to the 11, and because 4 plus 7 is equal to 11, so x to the 11th power is equal to x to the 4 plus 7 power, which is also equal to x to the 4th times x to the 7th. Remember, we can, if it's an exponent like this, you can break it down into two numbers that it's equal to and also break it down this way. That's rule number 1. Now let me do an example of rule number 2. This is just algebra, but sometimes students I used to tutor, they used to forget this rule or get them confused. So I just want to like really lay it out for you guys. So for rule number 2, right? Say we were to have x to the 4th power and this whole term, all of this, to the 7th power. Here, if it's one term to a power and the whole, all of the terms to the powers to another power, you multiply the exponents. So x to the 4th to the 7th power would be equal to x to the 4 times 7, which is just equal to x to the 28th. Also, x to the 28th power, since 4 times 7 is equal to 28, this can be broken down into x to the power of 4 times 7, since 4 times 7 is equal to 28. And then this 4 times 7, if it's times, it can be broken down into x to the 4th and all of that to the 7th power. If the exponents are timed, it can be broken down like this. Yeah, here's an example of rule number 1 and number 2. If you guys wanted to pause real quick and write this down. It's just, algebra, but it's really important to remember. All right, so with that, let's get into today's video. In this video, we're going to be doing scenario 1 for topic 2, where m and n are both odd. So we'll do an example for this scenario. So for the example we're going to do the integral of tan x to the 5th power times secant x to the 7th power dx. As you can see, m, which is the exponent of the tan function, is 5, and 5 is an odd number. And then n, which is the exponent of the secant function, is 7, which is also an odd number. So that would apply to scenario 1 because m, the exponent of the tan function, and n, the exponent of the secant function, they're both odd because 5 is an odd number and 7 is an odd number. Alright, so let's get started. Alright, so on the left side I'll be doing the steps, and on the right side I'll be doing the work shown per usual. So on step 1, for step 1, what we're going to do is we're going to break off a power of the tan x from the tan term, and we're going to put it into this format. And then after that, we're going to break off a power from the secant term and put it into this format. And then we're going to rewrite the integral. So let's get started. So what do we have so far? We started off with oops, why is my pen not writing? We started off with the integral of tan x to the 5th power times secant x to the 7th power dx. So we have to break off a power of tan x and put it into this format first. So we can take this term right here, and we got to break off a power. So if you remember from rule number 1, like I was talking about, tan x to the 5th power can be broken down into, well, 5 is equal to 4 plus 1, and we're breaking off a power, which is just 1 power. So if you want to break off a power, you can break it down like this. And recall rule number 1, tan x to the 5th power is equal to tan x to the power of 4 plus 1, right? And this, if you remember rule number 1 that I was talking about, this can be just broken down into tan x to the 4th power times tan x, which is basically tan x to the power of 1 to the 1st power. But, you know, anything to the power of 1 is itself. You guys know that. So I just wrote it like this. So that's basically how you would break it down from tan x to the 5th power into this format. In this case, this little box is 4 times tan x. We have to put it into this format because we want to break off a power of tan x from the tan term. Now that we've done that, let's break off a power from the secant term and put it into this format. So we got secant x to the 7th power. Let me put an arrow down and then do it over here. So we got secant x to the 7th power, and yeah, so we have that. So we want to break that down. We want to break off a power and then put it into this format, right? So secant x to the 7th power is equal to secant x to the power of 6 plus 1. We want to put it to the plus 1 because we're trying to break off a power. So it's always going to be something plus 1 if you want to break off just 1 power. So if you recall from rule number 1, this right here, secant x to the power of 6 plus 1, the exponents are added. So if you recall rule number 1, this can be broken down into secant x to the power of 6 times secant x. And this is to the power of 1, but anything to the power of 1 is by itself, as you guys know. So now you can see that we broke down tan x to the 5th power to tan x to the 4th power times tan x, and then secant x to the 7th power to secant x to the 6th power times secant x. For each of these, we broke off a power of the term, and then we put it into these formats. Now that that's done, let's rewrite the integral using you know, the broken off power of the stuff. So let's rewrite the integral now. So now that we have that, we can rewrite the integral, and the rewritten integral is going to look like this. It's going to look like the integral of tan x to the 4th power times tan x times secant x to the 6th power times secant x dx. Alright, so that's it for step 1. Now let's go to step 2. Alright, so for step 2, we're going to rewrite the equation such that it looks like this. This right here. Sorry, this was kind of a typo. I don't know why I didn't just put some white out on that like I usually do. Maybe I just got lazy when I was doing my notes. I'm sorry. Sorry, guys. But anyway, we're going to rewrite the equation such that it looks like this. It's going to be tan x to the whatever power times secant x to the whatever power times secant x times tan x dx. This just helps us with our algebra as we go on. It's not necessarily like a required step, but it's just really helpful with like the algebra and like the breaking down of the equation and stuff. So what we had before was okay. So yeah, so what we had before was the integral of tan x to the 4th power times tan x times secant x to the 6th power times secant x dx. So what we want to do is we want to put the tan x to the something power over here first, then the secant x to the 6th power, that's going to be the second term, and the third, the secant x to like the 1st power, the power that we broke off, that's going to be the third term, and the 4th term is going to be tan x to the 4th power. Then we're just going to bring down the dx. Like I said, the step isn't that important. It's just helpful for like the algebra later and just the process of breaking down the equation. So let's rewrite it. So like I said, that's going to be first tan x to the 4th power. Then next we got secant x to the 6th. Then after that, we got secant x. Then lastly, we have tan x. And then you can just bring down the dx. So yeah, this is the rewritten integral. Alright, so now let's go to step 3. Alright, so for step 3, what we're going to do is we're going to rewrite the tan term where the exponent does not equal 1. And we're going to rewrite that tan term in the following format. This format right here. Tan x squared and all this whole thing to the power of something. You can skip this step if that particular tan term is already like this after you do step 1. And a little hint, 2 times this box right here should be equal to m minus 1. Alright, so let's get into it. So what do we have so far after step 2? We have the integral of tan x to the 4th power times secant x to the 6th power times secant x tan x dx. Right? So we're going to take this tan term, because this is the tan term where the exponent does not equal 1, and we have to put it into this format. Now, if you recall rule number 2, well, let me just say what I need to say, then I'll talk about rule number 2. Anyway, tan x to the 4th power can be broken down into tan x to the power of 2 times 2. Now, remember, if you recall rule number 2, tan x to the power of 2 times 2, the exponents are timesed, it can be broken down like this. Tan x to the power of 2, and this entire thing to the power of 2. This is the something. This is the something. Basically, the something, or the whatever the box is here, is just going to be whatever this is divided by 2. It's going to be that divided by that, and it's always going to be 2. But that's why, if you do the hint, 2 times the box, 2 times 2 is going to be equal to m, which is 4. M, which is 5. M is 5. M, which is 5 minus 1. But I'll show you guys that later when we're done. Anyway, I'll show you guys how the hint works later. But anyway, now that we rewrote the tan term like this, we're going to rewrite the entire integral. So now let's rewrite the entire integral with the tan term like this. So, if we rewrite the integral, it's going to look like this. It's going to look like the integral of tan x squared, all that to the power of 2, times secant x to the power of 6, times secant x times tan x dx. And as you can see, the hint works, because if I do the hint, it's 2 times whatever's in the box, which is 2. It's supposed to be equal to m minus 1. Whatever's in the box is 2. 2 times 2 should be equal to m, which was 5, if you remember. M is 5, so that should be equal to 5 minus 1. 2 times 2 is 4. 5 minus 1 is 4. So the hint works. Yeah, let me just put hint here so people don't get lost. But yeah, this is the hint. The hint works, so we're on the right track. So this is what we rewrote the integral as. Now that we rewrote the integral this way, let's go on to step 4. Alright, so for step 4, so if you recall from equation 5, tan x squared is equal to secant x squared minus 1. So what we can do is we can rewrite the integral and replace tan x squared with secant x squared minus 1. So what do we have so far? So far after step 3, we had tan x squared, and this whole thing squared, times secant x to the 6th power times secant x times tan x dx. Right? So from equation 5, we already established that tan x squared is equal to secant x squared minus 1. Right? So if you were, since tan x squared is equal to secant x squared minus 1, we're going to take this term right here and replace this with this. So now let's rewrite it. Let's replace this and then rewrite the integral. Why is my phone going off? What is going on? Stop. Okay. Oh, side note, little side note. Can you guys, do you guys see my, can you guys recognize my screensaver? Does that ring a bell to anybody? Oh, I don't know if the light can show it, but who lives in the pineapple under the sea? Just thought that would be a cool thing to share with you guys, whatever, but I'm getting sidetracked. Back to the video. Where was I? Yeah, okay, so we were replacing tan x squared with this. So let's replace it. So if we replace it, we would get secant x squared minus 1, all of this squared, times secant x to the 6th times secant x times tan x dx. Alright, now let's go to step 5. This was a typo. I had to edit it out when I first... this was just a typo. Just please ignore this. But anyway, so yeah. So what do we have from before? We have the integral of secant x squared minus 1, all that squared, times secant x to the 6th times secant x times tan x dx. What a long thing to write. But anyway, whatever. So u is going to be equal to secant x, right? So let's take this derivative, the derivative of this. Du over dx is going to be equal to secant x tan x. If you guys remember your trigonometric derivatives, which I'm hoping you do. So yeah. So du over dx is equal to secant x tan x, because the derivative of this right here is this. So now we have to solve for du. So if you were to make this like a fraction and cross multiply, what we would get is du over dx is equal to secant x tan x over 1, and then we just cross multiply. Let me write that. Cross multiply. And then from there you would get du times 1 is equal to secant x times tan x dx. Secant x times tan x dx. So anything times 1 is itself. So du equals secant x tan x dx. So yeah, we solved for du. So from this step, we established that u is equal to secant x, and then du is equal to secant x tan x dx. That's really important. Alright, so now let's go to step 6. Alright, so for step 6, what we're going to do is we're going to rewrite the answer from step 4 in terms of u and du. And to rewrite it in terms of du, you solve for secant x tan x dx. Now, mind you, du is already like that. Once, like from step 5, when we solved for du was already equal to secant x tan x dx. But like, just in the case if it wasn't, if it was like du is equal to like 2 times secant x tan 2 times like secant x tan x dx, for example, or something. You would have to like solve for secant x tan x dx and get it like alone and stuff like that. But du is already equal to this. So in order to rewrite it in terms of du, you'd have to get it to this, but it's already equal to that. So you don't really like have to do that. Am I rambling? I feel like okay, basically what I mean is like, okay, say that like, just really quick. Oh, side note, my sticky notes are kind of like the notes in like the app for like the iPhone. How cool is that? Anyway, like say, okay, to rewrite in terms of du, you solve for secant x tan x, right? Dx, secant x tan x dx, right? I mean, du is already like this, so we don't have to do that. But just in the case of like, if du was equal to like 3 times secant x tan x dx, we would have to solve for secant x tan x dx, solve for just this here in order to rewrite it in terms of u and du. So if it was like this, you would divide by 3 on both sides, divide by 3, and you would get du over 3 is equal to, can you see the d like that? du over 3 is equal to secant x tan x dx. You'd have to solve for this if it wasn't by itself. But luckily, the situation that we already have is this. We have a situation where for us, du is already equal to secant x tan x dx, so we don't really have to worry about this part. I just wanted to put that in there in the case or in the situation that it wasn't, so you guys would just like know what to do and stuff. But now that it's not, you know, since it's not, you know, it's fine. Anyway, let's get into step 6. All right, so to start step 6, so what did we have before? So before we had the integral of secant x squared minus 1 and all of that to the power of 2 times secant x to the 6th times secant x tan x dx, right? So, like we established, u is equal to secant x, and then du is equal to secant x tan x dx. So everywhere that we see secant x, we're going to replace it with u, and where we see secant x tan x dx, we're going to replace that with du. So say I'm going to use some boxes here to show you guys what I mean. So secant x squared minus 1 squared, and then times secant x to the 6th times secant x tan x dx. So as you can see here is secant x squared minus 1. Secant x is u. So for secant x squared, we're going to put u squared. So secant x squared minus 1 and this whole thing squared becomes u squared minus 1 and this whole thing squared, because u, we're going to replace secant x with u. And also in the same way, secant x to the 6th power now becomes u to the 6th power, because everywhere we see secant x, we're going to put u instead. Now, however, here, for secant x tan x dx, for this part, that's just du. We're going to replace it with du, because as we established before, du is equal to secant x times tan x dx. Try not to get like confused with like everywhere you put everywhere you see secant x, you put u, because you don't put u for this part. This part, the secant x tan x dx, that's du. So don't put u for this part. The secant x tan x is du. I know that gets a little confusing since I said u is equal to secant x, but this wouldn't be u times tan x dx. This whole thing right here, secant x tan x dx, is du. So for that, we would just put du. So yeah, anyway, now that we've rewritten it, let's let me just like clear this up a little, make it look a little like more presentable. So it would instead, now that we've rewritten it, it would look like this. The integral of u squared minus 1 and this whole thing squared times u to the 6th du. Alright, so now we've completed step 6, so let's go to step 7. Alright, so for step 7, what we're going to do is we are going to multiply all of the terms out and then rewrite the equation. When I say multiply all the terms out, I mean all the terms in the integrand. The integrand is just the stuff in the integral that's in between the little squiggly line and the du, or the d, whatever, like just this. Just the equation that's literally inside of the integral. That's the integrand. So we're going to multiply all the terms out within the integrand. So what do we have? We have u squared minus 1, and this whole thing squared minus, I mean not minus, times u to the 6th du. Right? So that's what we got. So we have to take the integrand and then multiply all these terms out. U squared minus 1, and this whole thing squared, that would be, well, it's that times u to the 6th times u to the 6th, and this is the integrand, so we have to multiply all this out. So let's start off with this, with multiplying this, and once we get the answer for that, we can multiply u 6 times that answer, then get the answer. So we got u squared minus 1, and this whole thing squared, right? Let's start off with that. U squared minus 1 squared is equal to u squared minus 1 times u squared minus 1. So this squared is just this 2 times. So let's FOIL that out. If you guys remember from like high school math or college algebra or whatever, FOIL is first, inner, outer, last. So the first terms is u squared times u squared. That's u to the 4th. Outer is u squared times negative 1. That's negative u squared. Inner is negative 1 times u squared. That's also negative u squared. And then last is negative 1 times negative 1, which is just plus 1. These two are like terms, so you can combine them. U 4th minus 2u squared plus 1. So now that we have this, and we established that u squared minus 1 and this whole thing squared is equal to this, let's take this and multiply it by u to the 6th in order to multiply all the terms out completely. So u to the 4th minus 2u squared plus 1 times u to the 6th. Let's just be distributing, like using the, let's just use the distribution property, or distributive, not distribution property, what is it called? Distributive property, sorry. The distributive property to do that whole thing. So u to the 4th times u to the 6th. Remember, you're multiplying these, so you add the exponents. Remember rule number 1. You're multiplying these, so you add the exponents. I used to tutor so many people when I would do this topic, and if you're doing u to the 4th times u to the 6th, they would make it u to the 24th. No, you add the exponents because you're multiplying them. Remember rule number 1. Anyway, so u to the 4th times u to the 6th, that would be u to the 10th. Negative 2 squared times u to the 6th would be negative 2u to the 8th. And then 1 times u to the 6th is just u to the 6th. So this is the whole integrand, like multiplied out entirely. So now we've established that u squared minus 1 squared times u to the 6th is equal to u to the 10th minus 2u to the 8th plus u to the 6th. So now let's rewrite the equation. Now the integral looks like the integral of u to the 10th minus 2u to the 8th plus u to the 6th du. So that's it for step 7. Now let's go to step 8. Alrighty, so let's get started on step 8. We're almost done with the problem. But anyway, so for step 8, we're going to solve the integral of the answer we just got from the previous step. So what did we just get from the previous step? We just got the integral of u to the 10th minus 2u to the 8th plus u to the 6th du. So literally just solve this integral. If you solve the integral, it would be u to the 11th over 11 minus 2u to the 9th over 9 plus u to the 7th over 7 plus c. Alright, let's go to step 9. Alright, so for step 9, you take the answer from step 8 and replace u with secant x, then that would be your answer. Like we were doing in the previous steps, remember we made u equal secant x. So with the answer we got from step 8, we got u to the 11th over 11 minus 2u to the 9th over 9 plus u to the 7th over 7 plus c. Now remember, like we said, u is equal to secant x. So now let's replace, everywhere we see u, we're going to replace that with secant x. So now the answer would be secant x to the 11th over 11 minus 2 minus 2 secant x to the 9th over 9 plus secant x to the 7th over 7 plus c. And this right here is the answer. As you can see, I put a little smiley face here. Let me go back. Put a little smiley face here just for fun. I always like to end things out with like a conclusion. So I'm just going to do that. So in conclusion, what we have here is that we can establish with the example we just did that the integral of tan x to the 5th power times secant x to the 7th power du is equal to secant x to the 11th power over 11 minus 2 secant x to the 9th power over 9 plus secant x to the 7th power over 7 plus c. So that, yeah, that's the answer. And that's the conclusion that we got from doing this example. So yeah. I also did a second example on scenario 1. I did an example 2 of tan x to the 3rd power times secant x to the 5th power. As you can see, both of the exponents are odd, so then that applies to scenario 1. It's all solved out and everything, and like all the steps and all this other stuff, they're all solved out. And I'm going to put this in the Google Drive link. In addition to the example that I also just did, just so you guys can have like a second example and like all of my notes to refer back to if you like, you know, you're studying and practicing on your own and stuff. So yeah, there's a second example in the description link in addition to the first example we just did. It's all going to be available in the Google Drive link in the description box.
1, 2, 3, let's go!